h, I don't have something here, so it must be what? 0. So if I asked you, what does this graph look like? Where is the vertex? Can I tell where the vertex is?
Oh wait,
Oh, wait,
negative
no.
4.
Negative 4, so I know that when I graph this, that the vertex is going to be shifted over 4 units, so it's going to be at a negative 4, and since my k hasn't bumped it up at all, the vertex is at what? 0. Please, let's graph this. Let's graph x squared plus 8x plus 16 and verify that. So you are graphing x squared plus 8x plus 16. Kristen, can I use your calculator, please? And when I graph that, bang, there it is. The vertex is at negative 4. Now, we've been talking about, thank you, we've been talking about being able to identify where the vertex was. That was the homework that we've been working on in 5B and in 5C, those worksheets. And you know, if I gave you an equation y equals x squared, where's the vertex? 0, 0. Okay? But when if I said to you, I have y equals x plus 4 squared, let's go with plus 5, I know, Emily, that my vertex is being shifted over in which direction?
Left.
Left. Okay, so I know it's going to be at the negative 4, and in this case, it's going to be bumped up. This is my k. Remember the k for kangaroo, my h for horizon. So this moves it left and right, and the k moves it up and down. So when I said to you, I have a perfect square trinomial, which I had on the board a second ago, and we rewrote it, is it in HK form?
Yeah.
Yeah, okay. And it's helpful. Okay? Now, the reality is that most quadratics or trinomials are not perfect squares. But we're going to make them perfect squares. And that's why I had you drawing last night. Can you take something that is not a perfect square and force it into a perfect square? Yeah. Okay. So, pardon me?
You can square it, and then it'll be a perfect square.
Well, if we started with, so let's look at this one. I had x squared plus 3x, and I asked you to make a little drawing, and to make this a perfect square, what do I do to this term, the x term? I'm going to cut it in half, and in this case it's going to be what? 1.5, and if this is 1.5, what is there that I have to add?
1.5 times 1.5.
Okay, which is what, 2.25? Okay, so this has now been added into this.
How do you know that's 2.25?
Because 1.5 times 1.5 is 2.
Wouldn't that 1.5 have to be like half? No, I know, but wouldn't the box you drew for it wouldn't it be?
It is, it's the same dimension.
She's saying the drawing's not to scale.
Oh, I see, I'm not using the graph.
Oh.
Sorry, I wasn't using those grid lines.
Okay.
Yeah, absolutely right. It would have been, I'm sorry. It's, you know, I have a different perspective here when I'm right next to the board than when you do. Sorry. So if this was 1.5, and then this would, is that at a 1? I can't see it. It's like this.
Yeah, pretty much.
Close enough.
Okay, this is my half. And so it would be right there. Okay?
Okay.
All right. So I can make it. Could I write this now as a square number?
Yes.
What would this be as a square? If I asked you what are the factors, would it be x plus 1.5 times x plus 1.5? Okay, or x plus 1.5 what? Squared. Okay? All right, everybody good with that?
I have a question though. How can you do that when you're changing the equation?
Okay, we're gonna talk about that right now.
All right.
Next step. Okay, so I'm gonna change the problem. And I had written this out for you, and unfortunately I can't find it, so let me look at a problem for you. Okay. Okay, so what I'd like you to do is take out your little flip book, and we are going to add these notes in. This is going to be completing the square. This is called completing.
How much writing is it? Like which class would you use?
I would, depending on how big you're right, but you're gonna need a little, quite a bit of space.
Would this be enough space?
I think so, you write pretty small. Okay?
So like, I could fit it in there.
That might be a little tight. I think that might be better. Okay?
Wasn't it completing the square?
Completing the square. Okay, so let's start with this equation. Y equals x squared plus 3x plus 40. Okay, do I have a square number? No. Okay, so I don't have a square number. Do I know where the vertex is? No. Not in HK form. I haven't factored it. I have no idea where this quadratic is going to be in the coordinate plane. So what I'm going to do is I'm going to get rid of that 40. How do I get rid of the 40 on the right side? I'm going to subtract.
Is that y equals part of it?
Yes, y equals this quantity, so I'm going to subtract 40, and now I have y minus 40 is equal to x squared plus 3x.
Wait, why did you subtract 40?
Because I'm going to try to make this a square number, and it's I have a trinomial, and I'm going to make it a square number. So I'm getting rid of that 40. Okay, all I did was, so is my equation still balanced?
Yes.
I haven't thrown it away, I just moved it to get rid of it for the time being. And we're gonna deal with it. Okay, so I have this, and you just told me that I could make this into a square number by dividing that by 2. Okay, so I'm going to, and we could take notes, we're going to divide, well, how about if we do the problem first, and then we'll take the notes that go along with each line. Okay, so I know that I'm going to take my middle number, I'm going to divide it by 2, and what is that, so I'm going to have x squared plus 3x, and when I divided it in 2 and squared it, what was that?
2.2.
Plus 2.25.
Wait,
I took that 3, remember we had a square. We cut our, here was x times x. We cut our 3 in half, and I had 1.5, and this one was 1.5. When I multiply 1.5 times 1.5, what's in this square? 2.25.
So do we have to add that to the other side too?
Okay, hold on a second. So I'm adding 2.25. Everybody okay with that? All right. Can I now write this as, can I find out what the factors are? X plus 1.5 times x plus 1.5. And can I rewrite x plus 1.5 as x plus 1.5 squared? Okay, so that was my goal. Now, somebody said, may I erase my little drawing over here?
Yes.
So what do you do with the y track 40?
Let me erase that first, okay, Eli?